Hello and welcome to another wonderful evening of Rust. Today what we'll be doing is upgrading our tic-tac-toe to Super-Tac-Toe or Ultimate or whatever they want to call it. And first we'll always be playing the Clash of Code. I can't believe I forgot the name of that. And I gotta find my chat window and bring that to the top as well. For anybody joining the show for the first time, we're doing coding games in Rust on Coding Game. Yeah, it sounded a bit weird, but okay. And we just do it because we want to, and it's fun. And if you have any comments and questions, great. And if you know Rust, even better, because we're still struggling through some things. Let's get started with Clash of the Code. These are little 5-minute battles. Not 5 minutes, 15-minute battles. Oh, we got Petra, so... No golf, although not something fast. I can't think fast. Oh, it's golf. Oh, it's golfing, Rust, golfing. Input, the sentence on a single line. The value of each word in separate lines. The what? Okay, how do you split words? Split, I guess. For word in line dot split white space, let's just do that. It's I know split. This is going to be shorter, so split space is going to be shorter. Let sum equal word dot chars dot iter dot map c as u8 dot sum u32 print line. What is this works? S. I don't even know if this works in Rust. I have no idea. Of course we have errors. No method named iter in where chars is probably an iter already. Let's see if this works. No. It's not implemented. Well, fine. We'll do it I32 if it's not implemented for U32. Oh. Well, it's not implemented for that either, so let's just call sum. Maybe I have the syntax wrong. 132. Oh, come on! Now what's the problem? Well, maybe we better do it this way. We better say I32 and see what happens. That's strange. Oh well, it seems to work. Alright, seems to work. So now we're going to clean up all the crap. Get rid of print air. Get rid of this, so it's golfing. So code size, right? It's code size. I have the golf as correct, right? Code size, yes, there we go. You can see the code size there, which makes it smaller so we can see the whole thing. We got it as tiny as possible. I'll remove the white space last. We don't actually use parse inputs, so just keep testing this as we go. That should be fine. We don't need to unwrap this. Let input line, we realize this is shorter. There's nothing we could do about this other than change the name, so we can just call it L. We realize there's no way to make this shorter. We've seen this before. N with L. Nothing you can do. L.trimRight.toString. We may not even need to do that. Oh, the Python guy comes in at 72. Wonderful. And let's see if it still works. We can get rid of the temporary and just put this down here. L.trimRight.toString. We probably... Can we get away without calling toString or without even trimming it? I've got rid of that. See how small we can get this. We can, so we don't need to do toString. The split all white space, there is a function for that, but this actually ends up being shorter. We only use standard I/O once, so we could just stick it here. That's going to make it shorter as well. Perfect. We can call W here, w.charge, not much to do there. We can take out the temporary, kind of. But now we're going to have to stick it down here as I32. This one's actually getting kind of small in Rust, but I think we're getting close to the limits. Mut-L into for W and split point. Is there any way to reduce this? Is there any syntactic way to reduce this anymore? I don't think so. Charge.map, there's no way to reduce that. IS32, there's no names that are too long. The names are as short as possible. The sums as short as possible. The print lines as short as possible. Unless there's a way to print one number, but I don't think there is. I think all we have now is white space cleanup. I don't think there's a lot more we can do here. The names are as small as possible. Well, let's do partial whites. We're at 177, which is quite small. We'll read this stuff first. The simple stuff. And that gets us to 150. There's no easier way to do this. Del got split to get rid of that. This is as tiny as we can go still. C as I32, sum I32. I don't think we can do much more than this other than get rid of the final lines. Anything else we can do? No. I think that's it. I think we're all golfed out on this one. So let's do the final horrible step. 144. I think that's probably all we can do. Let's hope it still works. We're not going to get much smaller than this one in Rust. Oh no. Oh no, what does that mean? Did I lose my code? Did it submit or not? Well, hopefully we're still there. Alright, let's hope it actually submitted and we just got the next part failed wrong. And hey, we're up to 229 in the ranking here. Interesting. What are we overall? I haven't checked in a while. Oh, I haven't checked since. We're at the master level too. We won a game yesterday, so it gives us. That's mainly from the competition. So we're going to have to go a little bit of ways to get to Grandmaster. I'm assuming that's at 1,000 level. And we'll keep doing multiplayer. That's the way I'll get up to multiplayer, because Clash of Code, we do it each time, but it's hard to keep the score up. You have to keep playing. It drops really fast. Optimization here, we're done with. There's nothing more we can do. No, not with Code Golf. Code Golf we're done with. We're at the top for Rust. There's only like one of guys above us with one character in it, but we're at the top for Rust. There's no way we're going to get higher than that. Optimization is a place we have lots to do. We haven't solved many of those. But we're doing mainly multiplayer because they're more fun. So we keep doing multiplayer. And let's go over to that right now and see where we are. We were playing tic-tac-toe right here. We're in the Bronze League. That wasn't very hard to get to. We didn't even write any. We just wrote the rules for the game. It was. I'm really surprised we actually got that far with the rules for the game, because we didn't like any planning. I just filled in the things from top left to right, what was available, and that was it. Use an external editor. Oh, select a file. Should have already had one. Source/evening rust-private. Again, we're going to private. I've been asked not to make this stuff public, these games, because of the fact we tend to make it to a high gold or legendary level, and that makes it too easy for people to cut and paste. You could probably get through the code. If you watch the show and rekite it on your own, that's totally fine. Nobody's going to be upset with that. Take the ideas, it's totally fine too. We just don't want people copying and pasting it. Let's go over here. We're going to zoom in more until we can't see the submit button. Hey Sinclair, welcome back. So far in our tic-tac-toe, we've played basic tic-tac-toe. We can't play the big board yet. And today what we're going to do is make it actually play the big board. And we have to code the rules for that and change the state to support that. So let's get to it then. The basic rules, in case you don't know, Super-Tac-Toe. I'll read it again. When you play, or I'll just explain it. When you play on a small board, so on your turn, if it's your first turn, you can play anywhere, but then you're forced to play on a small board. So if I play an X here, or let's say here, if I'm on this small board and I play an X here, then O is required to play on this board. So then if O then plays up in the top right, I'll be forced to play up in the top right board. And it continues that way. As an individual board is run, so if I win this board, I'll get the X there. If O gets it, O gets there. And the winner of the game is who wins the overall board. If there's a tie on the overall board, then we count the winners of individual boards. And it's actually a fairly complex game. I've only played it once or twice on my own. And unlike normal tic-tac-toe, it's not very clear what the winning strategy actually is. So the approach we are taking is going to be Monte Carlo sampling, because that's what the game told us to do. And so we're just going to go with it because it makes sense. It's going to be tree-based Monte Carlo. We'll get to what that means later. And they're giving us 100 milliseconds. All these games are going to take forever to evaluate. A full game is up to 80 turns. So 80 turns times 80 could be, okay, 8 seconds. Not so bad. But in a leaderboard, that could be an issue. So 100 milliseconds. 1,000, this is because a lot of certain programming languages take a long time to start up. I don't think Rust is one of them, to be honest. Rust starts up fairly fast. Let's go back to our code. I got to close some things here, wherever it was. Strategy, state test. So the first thing we have to change is our state. We have like mini results, big results, game results the same. We have win-win, we have closed. But our state now differs. Our state has to be a bunch of little substates like this. Now we're just going to run this down as that there's actually 9 boards and a big board. And we're going to split this off. I think Rust is efficient for this, so we're going to split this off into 2 things. Pub struct tick board. Yeah, let's call it board. Or let's call it small board. Small board. And we're going to move a lot of the stuff to the small board. Small board. And then a lot of the stuff like print goes into the small board, get state, get player at, set place, set player at, next free. These all go into the small board. So we're just changing the way this works. Impl small board. Because the big board now has, well, yeah, because it's going to be split up into a whole bunch of small boards. Public small boards. And this is going to be a vector of small board. 9 of them. Love hard coding things. Don't you love hard coding things? And now, this is the one case hard coding is kind of, it's bad. But this value will never change. So just for clarity, I'm going to add constants. Constant board size. Board size equals 3. Let's just say 3 U size. And 3 means 3 by 3. And instead of having a 9 somewhere, well, let's do it this way. Constant board. And num cells equals board size times board size. Okay, and we're just going to clean up some of these things. So we have this here, and it just makes it cleaner to read. These values never change, and our code is going to assume they never change. But the purpose of constants is just make it clearer, because now it's a lot clearer as to why am I using up to 3. It's, well, I'm doing the board size. I'm not doing it to 3, I'm doing it to the board size. And here is kind of fixed though. See, this stuff here, this requires the board size to be 3. It's not like it can ever change. And so we have it here as well times board size. But this is going to be like this nonsense because it does as I32. So there's going to be some places where it gets kind of annoying, and we should probably have a macro that does that bit. Board size as I32. So like this bit thing, we could do we could do a macro for that, and maybe we should fix that right away. 9, and this is going to be board num cells. imod board size. I divided by board size. And this is board num cells. We have one mini board for each of the small boards, and we also have a big board. A big board. Did we actually win the competition? So the competition results came up. Let's open another window, because otherwise we lose this one. Where did we come in? 4th. Of course we came in 4th. I mean, it's Rust. Well, we did it fast. 50 characters. Oh, we should share our code because it's in Rust. And wow, we beat the Python guy. And Petrus couldn't get it shorter in C++. What did Petrusel do? Oh, yeah, that's the includes are kind of costly here. He probably could have got rid of the include vector, and you just include something like you include one of the iOS ones. Like some of the other iOS ones, like manip or something, include basically everything in the damn system, depending on the compiler. So you could probably get away with that. And using namespace std, he might got away with actually putting standards. Oh, it's hard to say which closer there. I think there's another printf, and I think there's a way to print out a number that's quicker. And what did he do here, though? Interesting. All right. Well, what did the tiny guy do? Python 3 at the top. It's hard to see what they do. Some or. All right. He took basically the same approach we did. He compacted even more. He had a join here. Whether that's actually more compact, it's probably more compact than a loop. Yeah, we probably could have got it shorter because we have joining as well. This is a nice solution. So there's no real for loop, well, except this part because you have to do that, and that's how you do iteration in Python. But that's pretty nice. There's a lot of Python, so Python here. And all right, but that gives us a few more points. We just do them for fun, anyways. Now back to here, we're doing big board. Big board is a small board. Yeah, that sounds a bit weird. Big board, small board, all board. Let's just call it a board. But it is a small board. Because the board comprises a small and the big boards, and the small board, and this big board is a small board. Whatever. I think that's clear. Because I don't want to call it a tic-tac-toe board. Or a TTT board, even though that might be what it is. And so the state test now has state default. Well, this is now actually a small board test. So we'll just do it that way. We're just going to do small board. This stuff still has to work. Small board. Now I'm in the wrong directory. Anything? Oh man, what was I doing today that I have all this stuff in my history? There it is, no capture. I want to get to the no capture because I forgot the syntax of that. Oh, of course we have errors. Oh yeah, it can't infer. This is kind of annoying. I don't know why it can't infer the types of constants. Okay, what do we have? We have a whole bunch of errors now. What did I do wrong this time? And it's compiling twice. I still don't know what it is. Entry. Oh yeah, entry. well, error entry is totally screwed now anyways, so we can just comment this out entirely for now. Because in the big board, this doesn't work at all. We're going to have to change the logic there entirely. So let's just comment that out for now and just do this. .36, Control 36. Get player at, well, let's just say as I32. 32. I really don't know why it's compiling twice. It's really bugging me. Right, so there's our output. And I actually wanted to improve this today just because it's more fun. I wanted to look at the box drawing Unicode. Because, hey, why not? Box drawing's fun. If I have to live with this stupid Unicode or Monicode font, I'll deal with it. And there's box drawing in here. I don't know which ones they are. I think there's more for Unicode, though. Unicode, I think, has more, but... aha, here they are. So for the small ones, you're going to use the small things. So where do we have this? We're going to do a... we're not going to do a print or repeat there. That was a fun attempt. Sinclair, it's a good question. Why don't I change get player at and set player at to take usize? Now, the reason I assign integers is because of my experience in history is that in general, when doing a matrix, and anything that needs to look stuff up in matrix, that might need to do any math on those operations, assign value is the way to go. Because it's more natural to use, and more importantly, you can have things like you can say, is this position valid? You can give it like a -1 and it could say, no, it's not valid. Because in our matrix class, we took I32 and this looks like a matrix. And so what I'm doing is I'm using my fallback position of basically the correct way to index in a matrix is signed values. And we'll find out whether that actually turns out to be the case here. Tic-tac-toe is somewhat different than a general matrix, but it's just my general fallback is to use signed values because it's the way to index matrices. Okay, so board size, we're not going to do this if wise. We're going to just print out the whole thing right now. No more repeat. That was nice while it lasted, but we have this line. Make fun Unicode and hope that it loves it. And this is this thing. Because then we can use the wide characters for the big board. And we copy that twice. We're going to better outputting like that. And it's not that character anymore. It's whoops. This character. I really hope. So that should give us a cleaner board with nice box characters. It didn't complain. There we go. See, that look much nicer here. We have an actual board now. That's more fun. And I really did bet we can get better X's and O's here too. X. I want a Unicode X. Or a Greek Chi. That sounds good too. Greek Chi sounds good. What O's do we have? Just to make this more fun, small letter X, Unicode X. X mark is actually more correct. There we go. There's an X in the middle. That looks more like an X that we want. But we might not find an equivalent O mark. But X mark looks more fun. That's like an X and an O. Now, is there like something called an O mark in Unicode? It's the opposite of the X mark, but there's no English equivalent. Oh, there's a white circle. Let's use that. We might have to use the heavy one. We'll find out what happens. Which one looks closer together. It looks like we'll use the heavy one. But I don't want the large circle. Well, that's wrong. What does it look like? X's and O's. That O looks too small and the X looks like it's in the wrong damn place, but... let's go with it. This large circle actually looks wrong. I mean, this font here looks wrong. It's not supposed to be transparent. I'm going to go back to an O. And the x's are now not aligned correctly, so I'm going to go back to normal x. Sorry, that makes it no fun. The lines are good enough, so normal x and O, unfortunately. Fortunately, we don't get the funness. But now we have to print the big one out too, and that's a bit more of a challenge. Hello, my dear friend Daza. I've had a good day. I've mainly done napping and went for a bike ride and went to the gym, so it's been really relaxed. If you notice, the camera is not flickering. Do you see that, Daza, way in the corner? I am not flickering today. I figured out how to get it not to flicker. Unfortunately, it doesn't save the settings. I have to set it up every time again, but I'm not flickering. That's a good plus. Okay, so how are we going to print this big board out? We want, for the big board, we'll have another print function. And this is going to be really challenging to do because it's not a graphics-based program, so I can't simply print out a small part of it and then paste it into the big part of it. I'm not sure how to do that. Unless, hey, Mort-ora-y seal, I really want to print this. Okay, so we're going to do a render function instead. Render. And I don't know how this is going to work. Oh, I've not done anything yet, Daz. Okay, so we're stuck in the problem now. I need to know how to render this big board in an efficient fashion. Because Regnagas Monte Carlo is, well, in this case it's tree Monte Carlo, and we'll get to it later, but basically tic-tac-toe, you have a tree of moves. The game is the basic tree-based game. It's limited to 80 depth, but that's a massive sized tree. And what Monte Carlo does is it says, in a certain amount of time, just walk down a random number of pieces of those trees. You might use filtering and logic and heuristics, but you're going to walk down a whole bunch of them, and for each node, you're going to build up a score that says how valuable it is to you or how dangerous it is to you, and you're going to pick the one that has the least danger and highest value. And you do not predict enemy motion in the random Monte Carlo. You just play both sides randomly. So for each step in the Monte Carlo, I take my turn, then his turn, and just keep randomly going down. That's how you randomly walk the tree, and you're just going to build up a whole bunch of these, so you don't actually have to predict what the enemy's going to do. You just basically look. I mean, you can start predicting. You can start predicting the enemy by basically, as you walk through the tree, as you start seeing a branch where the enemy has a higher value, you can assume he's going to take that one and only focus on that one. You're going to, of course, try to avoid that one, but you can actually assume it. So it's it does work for the predicting. You can basically predict, but it's just basically randomness. It's one of those things that if you had infinite time, you could perfectly solve the game. There's absolutely no way you'd fail if you had enough time. But it wouldn't be Monte Carlo, then that would be permutations. Monte Carlo gets pretty close to exact. It has a few problems. It can miss out value of things. And Regnagas, yes, it is random number generation, but you're doing thousands of iterations, and we're going to do pruning and stuff. It's not so hard to debug. That's why I'm setting everything up with proper tests right now, so we can actually see everything tested correctly. And I'm just trying to figure out a way how can I render this stuff correctly and quickly? You know what I'm going to do? I'm going to make a function called print line, print row, and self row usize. Daza, we're going to get back to that, okay? We're going to get back to that a lot. When I actually get into the Monte Carlo stuff, I'll go through very clearly and explain how that works and what it's doing and draw some stuff on the screen maybe. Now I just want to print stuff out because we need to debug this, and we're going to need to see the board state and make sure it's working. It's also just fun. It gives me some value of stuff we can do. So not y, so we have row, we're just going to call this y now, just to simplify it. So we don't have board size y, we have this. Probably could have ended it, and we don't need the print line at the end. So this prints out a row, and so we do self.print row y. And then we do a print line. And this is not a print line, this is just a print. That should have been an ePrint as well. ePrint, ePrint. And this is not a y is greater than 0. This is board size. This is 2 times board size minus 1. So if y mod 2 equals 1, we're going to print this. Else, we're going to print the other stuff. So what I'm trying to do is just iteratively print the board, because when we print the big board, we have to print 3 kind of in parallel. And this is going to be y divided by 2. Go get your food, Daza. We don't want you hungry. Alright, so do we still print? Did I not screw this up? We still print correctly. Very good. The reason I did print this way is because now when I print the big board, we're going to have to print the big board here. And the big board is going to be board size. And it's going to have y size as well. If y is greater than 0, then what do we print? Then we do an ePrint line. And we're just going to copy that stuff at the top and manually copy it. And we're going to put some spacing on the board. Where did I do that printing? Those fun characters, these ones here. So these little boards are all 3, 5, 6 wide, because I'm going to put a space in. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's already one there, which makes 6. 1, 2, 3, 4, 5. Okay. So we print the separator. Actually, you know what? I want the fat ones. Yeah, let's do fat ones. Hey, little mazes, cool. Let's go back to this. Do they have more lines? Oh, there are 2. We can just take them from here. Oh, but it'll easier copy from the Unicode one, from the web page. So I can use fat lines, so it's a lot clearer what I'm doing. So this is this one. Delete this. 1, 2, 3, 4, 5, 6. And now I want the big fat joiner. 1, and we'll copy this twice. Remove the final one. Okay, now for x in 0 dot dot board size, what we're going to do is print each line of the board. So for what? For I don't know, y prime. It's getting weird. In 0 dot in 2 0 dot dot 2 times board size minus 1. What we have to do is call small boards, and this is y times board size plus x as use size. This is the board we're referring to. This is a small board. I'm going to have to duplicate this a lot. This is kind of silly. And dot print row y1. y1. We're going to print that row. Then we're going to print a space on this. We're going to do an ePrint. It's going to have a space and then a vertical line, a fat vertical line. And do we need another space? Yeah, these should have spaces on both sides of them. Well, let's do it this way. In any case, we're going to print one space. If x is greater than 0, then we're going to print another, the fat line. Do the simplest way possible. We're going to print a space after it as well. But this means this is not 6 wide, this is 7 wide. Of course, the outside ones don't need the space, but we'll just simplify it. There we go, 7 wide. Print space, board line, and... No, I need this compactor. Let's make the outside ones not have the space. So if x is greater than 0, we're going to print this space like this. That'll be fine. What are you getting confused about, Daz? Is greater than, less than? Okay, if y is greater than 0, we'll print that line there. We're going to print the row, not self-print y, and we're going to print a line at the end, just an empty line. We need that on each one of these lines as well. Wait, I got this screwed up here. Daz, I didn't ever tell you the crocodile one. Just imagine it's a crocodile mouth. He's trying to eat the bigger value. This goes inside the loop, because for every line we have to print this. And then after that we print a line. And if there's after this, we're going to print an extra empty line. Well, we'll see how far this gets us. I think I'm missing it. I'm gonna get this formatted correctly. And let's do a big board here. And print big. Let mut s equal state default. s.print. Small boards, small boards, self-lit small boards. My test is not running because I forgot to mark it as test. We still have no idea why things compile twice. It's kind of annoying. Alright, so we've messed up. No, it's interfering with my output. Is there a way to run just one test? Cargo test help. I want to filter. Test threads equal 1 would help too. But is there a filter? Package -p? Try -p as well. I'll write that one down. Maybe p because I want to limit what we run tests for. Test name -test. I'm going to do -p tests. -test equals print big as well. Pass max no packages, so we'll get rid of that. No target test print big. Okay, how do we specify print big? Trying to figure out how I can say print big. I want to call it just print big. It says -test name. But how? How? Or do I have to put... I'm putting it in the wrong place. It's not finding print big. That's the issue here. Well, let's skip it for now. Test threads equals 1. And hope it doesn't interleave the output. Test. This is also not known. -- test threads. Oh, after the -- I don't understand why there's the -- here. Alright, so at least it's not interfering with it out now. Well, it kind of is, but should know it's still interlacing my output. Cargo test 100. Cargo test print big. So we shouldn't need this then either. We don't want to capture it. Oh, that worked. Alright, so it just printed the big one. And it seems to put it on a different line. And obviously our output is totally screwed up. It's done something horribly wrong. Let's make sure the normal print is still working. Normal print still works, so we're okay there. It's just the big print has gotten something horribly wrong. So let's get big print working correctly. We have y is greater than 0. We print out this line. That should be fine. Otherwise, for each board, we're going to go through the board size plus 1, so that makes 6 lines, and they each have a line. And if x is greater than 0, I've got this backwards. This loop has to be like this. For each of these lines for the small board. So we're going to go through the 6 lines, and for each of the small boards, we're going to print this out, and let's see if that's the issue. No, if x that way. Getting closer, getting closer. It's not supposed to be -2, it's supposed to be -1. Okay, and if y is greater than 0, we're going to print that line. But I want 2 lines here. ePrint line. I want a space in between as well. Okay, so that'll give us the boards. It's not quite as compact as I'd like. Maybe I shouldn't put the extra line. Maybe I should just pack them together because they're already going to be spaced out enough, and we want to see this in the outputs. Alright, so that'll give us this. That'll give us the big board, and that's just for debugging that we can do this. I don't know if we can set this up randomly, but we can't see the overall board, which might be an issue, but we'll worry about that later. This at least gives us the subboard states. We don't have the big board state. We can put the big board state over to the side, but let's do it this way. Yeah. Well, Daza, there's not supposed to be padding between these lines. This actually means this console is technically broken because these lines should be full height. And for a console, though, that's really annoying to get right. So I can totally understand why there's little dashes here. I'm leaving the padding on the small ones here because otherwise they'll be packed too closely together. But this should be okay. That should give us to see what the big board looks like. I assume the rest is correct because the small board was correct. So now we actually have a big board being printed out. Now we have to implement the rules of the game. So that'll be enough. let's get rid of, we're going to go over to entry now. Entry, we're going to have to start parsing differently, see what it says for that. Well, it does. I don't have any padding at all on console. Remember, this is just a text console. It's just monospace font drawing. And, hey, wait a second. How can their action be expressed by just opponent row and opponent column? It has to pick two places. Something's wrong here. Something's wrong in their input. This can't be right. To make a move, you have to specify which board and which small board. Does it just actually mean this is a 9x9 grid now? Maybe that's what it means. Maybe this is a 9x9 grid. Can we assume that? Zero, 1, 2, 3, 4, 4. Okay, so it confirms. Euler-Stahl confirms it's a 9x9 grid, and that's what they're specifying here. So they've ignored the substructure. We're going to keep the substructure because it's going to be extremely important for the rules and for the decision what's valid there or not. And we're just dumping this valid action count. We don't need to parse that. So this is why possibly it was actually working before. State row column, O row, O column. And now we need to do in the state, we'll just parse the input, because in the input state is the correct place to parse it, because this is a weird format. And so what we need now is, I'm hesitant to say get board because that's going to screw up the boring rules, but let's start with that way anyways. Get board and mut-self. It's going to have these borrowing rules because, hey, we love borrowing rules. And again, these could all be U-size, but again, I do the fallback. The correct way to index matrices is with integers. This seems natural. Why would I use anything but an integer? And we can optimize that later, but it won't make a difference. Casting should be free. And this returns a small board and a and small. If anybody's wondering what the ugliness is the lifetime. We're saying that this reference in the return is the same as the reference itself, so it can actually do that. We're just going to assume that this is correct now, these indexes. And so we're going to return self.smallboards and mut-self small boards, and this is going to be, and we should probably do an actual, okay, the third time, is that the third time it comes up? Y times port size plus X as U size. No, we don't even need the return. So that'll give us the small board. And I wonder if we should maybe do an index. Student, I have to keep looking that up a lot. Yeah. This is actually going to be a function and not actually a macro, so we can get the actual index, get board index. And we've already declared them pub, so it should be okay. Get board index, and we don't need this then, just and self. We don't even need self there anymore. I'm going to put self though, because otherwise the calling convention is going to be inconsistent. This is going to be a use size here. We don't even need to get board anymore. So this is going to be the more rusty way. So eventually we're going to do a let small board equals state.getBoardIndex. And now we do state.smallboards.setPlayer@. Oh wait, we got to do this. We got to split this up. Sorry. This is actually divided by 3. And this is opponent column mod 3, opponent row mod 3. And I'm starting to think that maybe, just maybe, we might do it this way as well. I'm not stressed today, edA-qa. Alright, so that sets the small board up that they have there. And we do a print, state.print. Now we have to find the next free one. Moderate seal, it is a super weird syntax. It's a Rust thing, and it's a lifetime modifier. And I try to avoid them, but they're necessary. Now when I have this player's move, I have state.setPlayer at this one. This tells us what the next board is. I'm probably just looking with my eyes, edA-qa. I can't see the screen sometimes. And my neck's sore. My neck's often sore. So it's in my hand here. So how do it goes? I have to encode this to get the board index. And SB index is -1. In SB index, this is the basic rule. I don't like the rule, setting the rules right here though. But I don't know where else to put them right now. State.getBoardIndex right here. Thanks, edA-qa, but I've got lots of exercises. They help, otherwise my neck would be painfully sore. Now it's just slightly sore. Okay, so SB index. This is the board, the next board I get to choose. And maybe it should be an enum. We're going to make an enum right out of this. We're going to make an enum. Make it one of these types of enums. Pub enum board index. And this is going to be any or none. It's hard to say what it, and board I32 or cell I32. This actually has an index, none or index. I don't know what to call this thing. It's either a board index that has none or it has a value. Board or cell I32. And we're going to implement the default for that. Implement default for board index. We'll get back there, Steve. I think it might have to, because I have to reassign it. And this is a big Rust question here. I'm uncertain why I can't do self none here. I tried this down here, self open, it complained. I'm going to try it again. But, okay, so the reason why... Thanks, I'll try to balance coins. The reason why this is a mutable is because I reassign it in here. Board index none. And this is board index cell. Now, I have to encode the rules here. And I got to move these rules to the state because as we do our look ahead, we're going to have to actually iterate these a lot more. So we're going to have to encode these a different way. But let's just get this here working first so we can at least do something. We'll at least see ours play the game. So this is basically here now we have match SB index none. We get to do something here. And cell I, well, it's a small board. Do something here. And in this one here, what we want to do is we want to get the board. We're going to translate. What do I want to translate? I want to translate. Sorry, I want to do the. I want something like this, whatever this is. Let nx equal state.smallboards, smallboards sb.next free. That's the one I want to do there. And then I want to output nxy. Well, ideally, I'm just going to do this all once. So let's put a bunch of mutables out here. Let mut small board be a usize. Let mut nx be an i32. Can you declare multiple ones? Mut ny be an i32. I don't know if you can pack these together, so it's going to be more like nx equals qnx and y equals qny. Small board equals SB, got to have a different name, SBX. Different name, SBX, SBX. And so this sets up the turn. So this is a turn we take in that case. So we get rid of this, set player, state small boards, SBX, set player at NXYCP, print line. And now we have to do this. We have to convert back to a nonlinear index. Let me think about that for a second. How do we convert that back? I have the cell index. And we'll make functions so it'll be, and it's row first, which is really annoying, SBX divided by board size plus NY. SBX mod board size plus NX. And these are slightly reversed because of their system. Now if they choose none, what do we do now? Well, we're going to make a mistake first of all. Let snx, sny equals state.bigboard. And because we don't set up the big board yet, this is actually invalid, but it'll at least let us see if the thing's running. SBX equals snx plus sny times board size. This gives me my linear index as usize. And then we can do this as well. SBX, usize, NXQI, NXQY, and that'll get us whatever it is. And we'll see if this actually, no, I don't want to run a test. I want to do clear and cargo build. Open this up a bit more. Again, I don't know, RLS just quit working. Sometimes during the competition, RLS just decided it doesn't like our structure, and so we don't get any of the features of having a built-in Rust support into Visual Code. Get board index 159. Pub function get board index. entry. We have to pub these as well. Pub. Maybe that was the whole thing. Not found in this scope. We had to. Well, we have that. Alright, so where do we have it? So this has to be board index, cell, board index, none. What else do we have for errors? No field state, small boards.state. What do I call that? Small boards 38. Small boards SB. Yes, get board index. Mismatch types, board cell. Cell, what do I call cell? No, this is supposed to be a use size. Alright, what else do we have for errors? This is the problem with mixing use size and stuff. Trying what's the best way to do this. I'm going to convert these all to use size based on the logic that in the game of tic-tac-toe, you never actually refer to left, right, and up. We're not doing any board logic whatsoever. These are all flat cells. We really just don't care who or what direction these are. So X should just be I32. And these are all just going to be use size anyways. Use size. And so this isn't actually a matrix. The tic-tac-toe board, while presented as a matrix, is actually just a random set of 9 fields with 9 conditions. It does not behave as a matrix in any form whatsoever. Use size. Let's do this way, use size, or get rid of that one. Oops. And I screwed that other one up, didn't I? That's why I should have had a macro. Alright, get rid of that. Where's our next I32? Use size. Use size. imod board size. And this should simplify it a bit. Use size. And over in here, let's get rid of all the I32s in here as well. Use size. Use size. Come on. Use size. Use size. Oh, this has to be an I32 because it could be negative. As use size. Put these on new lines just so it's clear. Oops. Repetition, not so good. It's use size. Valid action count, that's fine. We don't use those anyways. Okay, good. Oh, now we got more errors. Expected. oh, this crap here. They have weird precedence rules. I don't like the precedence rules. To me, as should be lower precedence than an operator. I find it really strange that as has such a high binding precedence, because it doesn't look that way. It looks to have a very low precedence. And AP, this is alt player there as well as use size. Yeah, this is what I mean here on state RS. I can't figure out for the life of me why here in Rust, why the self works here, but you can't use it to refer to as an enum here. It seems something's missing here. Why not self none? I know we'll post that off in the user forum sometimes because that feels like an inconsistency. I just don't understand why that is. And what did I do? Oh, I have a -1, tree 49. Get player at, uh-oh. Well, get 2. Player 2 is going to be that other value now. 2, 2, 2, 2. 2. Let's just simplify that. Whoops, I pressed the wrong button. 2. Alright, so expected 119. Where's that? Oh, right there. It's supposed to be 2. Well, it does something. It compiled, and I guess it probably submitted it. So let's see if we play a game or not, or we fail. There's a chance we fail because I said one of the things we do is incorrect because we don't set the turns correctly still. And oh, their output's not monospace. That's fine. That's what you'd expect. But what did I do wrong? Eliminated! Invalid action! So, I played X, he played O. And then I'm supposed to play down there, and I did 2-0, which would be here, which is obviously not correct. So I played in the wrong damn place. And again, we did this because it's a row column, and we got those backwards again. Column, row, small boards. Divided by 3 is use size. Get board index. Did we print it out, though, correctly? I see we meant to play down here, so we have a transpose. This is what we meant to play, I guess. Or maybe not. And this is 0 down here. So he put his in the right place. And what do we have down here? We did something wrong down here. Let's print out what we meant to do first. We have 3 values. We have an SBX, an NX, and an NY. And those 3 values determine our turn. Replay the same game. Okay, and so we printed out 600. And board 6 is this one here, 0.00. So we actually chose the right thing, and we just output it wrong. So 600, this should have been, and, oh no, wait, there, I calculated this wrong. This is their Y, and this is times SBX divided by board size times 3. well, it's kind of times board size, but that looks really weird. And this is also times 3. Now we'll see if we play the game. So at least we play the game now, and we're probably going to lose. But okay. And this is what I mean about elimination. This is the one we know it's wrong, because we don't actually set the outermost game state. We played 0, 1, and we put the outermost game state. So we're definitely wrong there. We picked the wrong place. And we're going to fix that. We're going to move the stuff over to the state first of all. Instead of doing this stuff here, we're going to do something simple. We're going to say SBN index equals state.takeTurn, and this will be player state.altPlayer, and this will be at this board index and these bits here. So they're going to take their turn at that point right there, and it's going to return the value of what actually played there. An SB index is a board the person has to play on next. So we have to write a take turn function. Public function take turn. And this will be board, small boards is use size, X is use size, Y is use size. And this returns a board what? Board index. And this will be at return. Position the next player has to play at. Okay. And what we said is it did this, we'd take self dots, and this has to be immutable. Self.smallboards SB set player at X, Y, and this actually had to take a player as well. Player is a use size as well. Where's player? And what it returns what it returns now is okay. We're going to check the small state of that board. We're going to do a match self.smallboards speed dot, what do we call it? Get state. Get state, and we have open, win, and closed. Get state, and we have what did I call that? Game result. Open. And open does nothing then. Actually, no. Open is going to do something else. Match. Game result. Win. Player. Because we have to match the things to the main board. So the main board has to have these values as well. Closed. And so if it's open, then we have to return this one. So this actually returns something. Opening means we don't touch anything. So we take the board index, cell, state.getBoardIndex X, Y. And that's when the next player has to play. So I'm just saying when it's open, so if the small board remains open, that means the move, wait. Sorry, I've got that wrong. If it's open, nothing happens there. We'll get back to that. if it's win, then we take the self.bigboard dot set player at. And we need the index of the SB. This is getting annoying. Do I have a set linear? Let's just create a set linear up here. Set player linear, and this will be self.setPlayerLinear bit xy player. And this takes a bit, I don't know why I call it bit usize. Wait, no, that's not correct. It's the other way around. Set player linear. And now we should probably test this stuff. Becomes self.setPlayer at. And we need an index at usize. Mod board size at divided by board size player. And we should probably test some of this stuff a little bit. Because hey, that makes sense. Set player linear. We're getting too much here to do all at once. Big board is set player linear, and this takes the small board. This goes to player. Do S player just to distinguish S player. So this means if the small board the person just played at has a winner, it goes to the small player. And now the close is going to be a bit weird because we can't necessarily store that state, but we want to store that state. We want to know at the big level what's the status of that one there. Actually, you know what? This is a we have a new status. We have something more than just we have to be able to mark a board cell as like just blah, done, with nothing on it. And how do we do that? I'm not sure how we do it. We're going to fill it up. Maybe we can fill it up with player 3. So the problem here is that when the small board is closed, we have to mark the big board as being not available. I don't have a way to do that yet. Had we done the board as suggested yesterday with 2 bits per cell, we could have actually done this, taken the 3rd bit to say basically the cell is off limits. And because we have tests, we can actually change that. So let's change that now. Let's start running the tests. Oh, but that's going to be a pain in the ass. The calculations for winning are going to be a lot more annoying then. how can I do that? But we do need to store a third state, which basically says it's unavailable, and I don't want to do a third bitmap. Though that would be the easiest. Simply adding a third bit mask here would be the easiest way to do this. Makes the number larger though, and we want small numbers because that would be 3/16. Because we definitely know we could store this in a... We only need 18 bits. Well, let's do it this way for now. 3. And that basically just means we have a player 3. And so we have it right here. We have a player 3, but they can't win anything. But they can block the board. Player 3 can block the board, but they can't win anything. So they go away, get player at. Player 2 doesn't matter. There's no player at there. Player at set play is set player at. The other set should work. Except the set player at 2 is now... Alright. Pub const. Player clear. Use size. I'm going to set him to 3. And all the other players are valid. And what do they do? The 2? Let's just look for the magical number 2. Oh, there it was. 2 is now blocked. Let's put a dash in there. And player clear. It's going to be space. Yes, Daza, we always miss you. Player clear. Look for the next 2. This is player clear. And this should technically return this as well. Well, let's just do it this way for I in 0.3 use size. Although I don't know what it means if it returns a 2. Otherwise it returns player clear. Player equals player clear. We're going to clear all of them. For I in 0 dot dot. I'm doing this hard coding again. Because I don't know what that's called. I don't know what it's called. It's not really num players, but use size. Yeah, we made progress. Of course we made progress. Else self dot player or equals bits, and we just won't check for validity there. Next, self dot board. So we fill it up here as well. So this third magical player can fill oh, you don't know or equals. This is classic C syntax. This is bitwise. This is a bit or. So this bit mask or this bit mask, whatever one's 1 becomes, on either one becomes 1 in both of them, and is says has to be and in both, and not bit is a bit complement. I actually don't like the C syntax for it. It's good in some cases for optimization, but it's actually not clear, and as you say, for people that aren't used to it, it's really kind of opaque and weird. In Leaf, I use bit syntax exclusively, so in Leaf you'd have bit or and stuff, just to make it very clear, because they're not actually used that much. Some cases in optimization, but overall, bit operations are not used that often. Well, by the end of this, you should understand what the bit operations do. Now I'm lost. Now we have errors. So let's get through the errors. 97. This is a use size. And again, the errors are coming out twice. And anyways, well, get better soon, Daza. Oh yeah, this has to return something, so I can't comment it all out. Oops. I'm sure it's not that bad, Daz. I'm sure you'll survive use of board state. So I knew this would come up right away. Whoops. And this is because of that. This is actually a defect that is fixed in Rust, but at the moment it isn't. Arguments incorrectly take their lifetime. Mort-ora-y seal, the reason I'm keeping track of that is because I need to know that who wins the big game. So when you look at the game, I need to keep track of who won that big game cell, because it's the big game that determines who wins the game overall. And so I need to track that state. And so basically I have two versions. I have the small games and the big one. And then the big one also has the block state. And that's why I'm keeping track of who wins the small boards. Technically, I could look at the small board every time, but I already know that's going to be too slow. So I'm doing it optimized this way already. Aha, I knew there was a -1 hiding in there. 21. 21. Well, that's not in the 21 tests. Yeah, tests. Player clear. I hope that's good enough. Well, we should run all the tests. Oh, you didn't ask why, you just asked R, but yes, I'm keeping track of that. So this is all the tests pass. Now, alright, what was I doing? The state now. So I had this one. So when we take a turn, the player takes the turn. We get this board at the turn to take, and if it's open, we do nothing to the big board. If it's won, we set who won in the big board, and if it's closed, we close off the big board. SB, comma, well, I'm going to put a player close here. Just be clear, player close equals usize 2. We just close off the board. Player close. And that's a small board. So now what we do is we check X, Y. We need to know what the state of the board is at the big board. So we're going to do match self.bigboard. This has to be dot get player at. And what was the big board? X, comma, Y. No. Get player at linear. No, X, comma, Y. Yes, X, comma, Y. X, comma, Y. If this is what did I say? Get player out? This is player close. I'll clear that. Player close. There's only two conditions here. It's player clear. In this case, we can return a value and anything else. And so we're trying to figure out where the next player goes. Now we return board index none. That's the next position. Otherwise, we return board index cell. And how do I get the cell again? That's self.getBoardIndex. And this is probably going to whine at me for here. X, comma, Y. And so this last bit says what the next turn has to be. All right. Did we do that correctly? We have, when they take their turn, SB index. Good. That should be correct. So now at least we shouldn't make invalid moves, and we're not going to play the game very well, but at least we don't make invalid moves. And we made an invalid move. And what did we print out? Does the game state look correctly? Hey, it doesn't let us see the individual state. Okay. That's fine. They won, they won, they won. And what did we do? We played at 4, 0. We tried to play in this board here. Well, that was stupid. We played in the wrong board. Because where did they play last? 1, 6. 1. We have to remember, I'm inverting this. They played 1, 6. They played here. So we meant to play there. And we output in the third cell this one here, which is correct. Oh no, that was free. Well, let's see what we're getting out from here. Or we should start testing these things. I was reluctant to build test cases. I just want to see it go about the board. We actually have a test case there. It should do something. So let's write a few tests here. Fn turns let mut_s equals small board. No, this is actually state default. Let q equals state dot take turn. I forgot what take turn is. Take turn takes the player, the board, and the index. So take player 0, I'm going to say board 1, which is the second one. We're going to put it right in the middle, 1, 1. Which is really silly. Insert equals, and this will be board index. So I played right in the middle, so it's going to have to be board index 4, q. No, I don't want print big. I want all of them. And now we'll leave the capturing on. We don't need to see the printout anymore, I think. s.take_turn board index cell. Okay, so that works. So I just do a really quick check, and then we're going to let q equals s.take_turn as we player 1. And they have to play in board index 4. And I'm going to make them play then in the same place. This is board index 4. I'm going to make them play right at the same place because we know... Oh no, that's still occupied. I got to get one to get filled up first of all. So let's fill up the board. Q.set s.smallboards. It's 4 dot. What do we call this thing? Set plays. Set plays for player 1, and we'll fill this up a little bit. So it'll be 0. 1, 0, and they're setting the middle one, so we'll leave that blank, and 0, 1, 0. So what I'm trying to set up is that after this next move, they'll have won that spot. And so this is board 4, and they take this turn. Now we're going to say that assert equals that board is going to have to, because that board is now free where we have to go, this has to be none. And we also want to assert equals that s.bigboard dot get board get player at And this is again 1, 1. This should be player 1. And this is probably going to bitch at me about all my unsized stuff. Get player is private. Interesting. Get player at. Might as well just make it public. And it passed. So we're doing that correctly. So why did we screw it up in the game? Something went wrong in the game. So does their board look like theirs? O wins, X's and O's, X's, an X, 2 X's, 2 X's, a big O, and an X and an O. And I wanted to play at board 3, which is over here. But I shouldn't have. Somehow I have to show the big board state as well, because this is not going to be helpful enough. I need to show the big board somewhere. Maybe down here. Or maybe afterwards, if I have enough output left. Let me do an e-print line, because there's something going wrong with that. The basic test shows it working, but the big one doesn't. And state.bigboard.print as well. I don't know which one should print which. I don't know, clear and cargo. Probably already built it though. Okay. Now what I don't have is I don't have marked the fact that I won that board. I know why. I know why I screwed that up. Because the player isn't taking the turn here. I'm just doing a set. State.take-turn. This has to be take-turn. And what is the ordering of that? State.player. So this is CP. And this is board SBX, NX, NY. So that's what I was doing wrong there. I was forgetting to take my own turn, so I wasn't marking my own spots, the final spots, correctly. So now hopefully I just lose. I won. How do I win this? I don't have a strategy yet. Alright, but we play the game correctly, so let's submit it. And you know, the rules are complex enough that maybe you get somewhere with just playing the game correctly. But usually that's Wood Leagues. Usually to get out of Bronze League, you have to actually have some strategy. Wood League is just there to make sure you're playing correctly. So it's going to be kind of 50-50, I guess. It shouldn't, unless if the boss is random as well, we're going to have 50-50. If the boss has some logic, then we're not going to get nowhere. The boss is okay, so it might actually be 50-50, or actually because we're doing an order, we might have a slightly better chance of winning than random. So we may not fight enough battles to do it though. But again, slightly better than random because of the ordering we do. We don't know. I mean, the next step obviously is to do an actual logic here to it. I mean, I already achieved the first goal for sure I wanted to do tonight is actually get the rules encoded. And it doesn't look like we ever lose a game because we failed. We made the wrong move. Now we're actually going to have to get into our Monte Carlo sampling type thing, and this is the copying state and stuff like that. And a depth of 1 might be helpful, but we're really not going to get higher in these charts, I guess. Although we're winning a lot of games. So I guess most people are still just working on their basic rules, which means most people are probably trying to set this up to work correctly, because the game actually tells you your valid moves. All you would have to do is pick one of the valid moves and go with it at random. And we've chosen to actually calculate ours because we know we need to do the calculation in the next leagues. But this output they have here is really just like a convenience help you play the game type thing. Oh, and this is going to be one of these cases too, that just like in the competition, if you have a bunch of people messing with the bot that keeps failing and playing the boss, it's going to push the score up really high. But again, if we just have any logic, it should be no problem whatsoever. And we're still going up though. In theory, we might be able to actually beat this boss just by randomness, because if it is random and we have a bunch of people actually just trying to get the code working, it's hard to say. Let this run for a few seconds and I'll be right back, and we'll see whether this is enough to get out of this league, but I kind of doubt it. All right, where we get up to? Oh, well. Okay, so it looks like we could make it out of the Bronze League, again, simply by having the rules of the game. The way I pick is I just pick the next free cell in linear order, and so in given a board, a little matrix, I just pick the one from the top left, scanning that way. And because that produces a pattern of filling, that's probably good enough to make it by random. And if the boss is just using random, then we could get far enough. And if most of the other people are just working on getting their bot working, which seems reasonable, then we could probably get to that one. Because we're still going up. So again, that should get us a Silver League at least. And this is basically just the rules of the game. Or maybe not, we're going down, so we'll have to see. Ah, no, go up. I just want to let it run to see what happens. If we get the Silver League, then I can start working on the actual logic tomorrow. If we don't get the Silver League, then I'll start working on the logic today. But again, what we'll be doing is Monte Carlo trees. And I've never actually known the word tree before, and I looked that up the way, but it's basically how I did Monte Carlo before. The last time I did Monte Carlo was for poker playing. And in poker playing, you use Monte Carlo sampling a lot. Because you don't know what the other players have and you don't know what the game's there, you just iterate through like millions of combinations, and the poker bots are optimized to really do millions of checks. And how fast you do a check is important. But poker's a much shorter game, than Super-Tac-Toe. There's like in the Texas Hold'em, there's only like 1, 2, 3, 4, 5 phases, so, or 4 phases that actually have to be evaluated, so it's much easier to go through. Tic-tac-toe can go to a depth of 80, I think, or how many squares are on the board? There's 9 times 9, there's 81. So we'll go down to a depth of 81, and that's the potential depth, so we're going to have to optimize out of that. And what that means is for when we pick a position on the board, and let me show you around it. So it's my turn right now. Let's say it's my turn. And I guess I can't tell from here, but let's say he just played here. And so now I have to play here. I have 7 possibilities. And since this is where our tree starts, we spawn, we have 7 children in the tree. It was bet throws up to 7. And you have to do all 7 here. You can't start with random on the first level, otherwise you're just going to go crazy. And from there, when I take those 7, then it opens up his next move. So say I take this one, the square here, then I go to the middle and I say, well, now he has these 8 possibilities. Let's just pick one at random. We'll pick this one. Okay, he picked up there. Then I go up here, I pick one at random, and I keep going through randomly down until I get to a condition where the overall board is won or lost or tied. When I get there, I take that value, and if he won, well, I keep track of the scores up the tree, and every time there's one that wins, his win goes up, and my win goes up from mine, and the count of the number of simulations goes up, and the number of ties goes up. And so you have one score, you have a win minus loss score, plus the number of simulations played. So when you get back to the top level, all 7 of these things have a score. Positive scores are for me, and negative scores are for him. And what I want to do is then, you want to take the one with the highest positive score. But to do the tree correctly, you know, that's actually the simplest way, and we'll start with that. We'll just take the one with the highest possible score. But there's also confidence intervals involved, and this has to do with the randomness. Things aren't quite random. You're going to want to start evaluating not quite random. I mean, you're going to have confidence intervals. Like if I see one that's winning here, so the moment I see that playing in the right corner here has a slight chance to win, I'm going to start doing more iterations on that one to improve the confidence interval. Because the more I do, the more my confidence goes up. If he keeps winning, then it's like, well, pick this one. And because that makes a lot of sense then, that the higher confidence interval, the better you want to win. The safer it is to go there. Whereas if you have one with a confidence interval where you lose, it's a very high confidence interval, but there's no point in evaluating the losses because you're just going to avoid it. So this is how your your tree pruning is done. Is you just stop looking at the ones that have losing values. You say, hey, this is losing, but that's one of the limitations of Monte Carlo, is that the moment you stop looking at a branch, you're like, well, there could be winning conditions in there. It could be just that your first few searches in that tree came up with losses. But in general, it tends to work out, and we'll see what it is. And it takes a little while to set up the tree. Most importantly, we actually have to set up the game to play itself to the end and come up with the scores coming up. And we're not actually going to do the tree. This is going to sound really stupid. We're not going to do the tree because that's really complicated. What we're going to do is just per cell. We're going to take these 7 cells and randomly play to the end. I'm not going to keep track of the whole tree initially because that's very costly to do, but it has a really, really big value to it. It's the reason why you'd keep the tree the whole time, and is because when you go down through the tree, at each level, you're going to start choosing the most logical ones. And this actually, for the player here, like when the second player goes, the O player goes, this is how you actually get the mini-max strategy into this, is when you get to his player turn, you're also going to have a tree for him that says what his best move is. And so you're actually going to choose that. You're going to choose his best move for the opponent as well. And you're going to start looking through that. And this gets really complicated as to which tree you pick. I mean, the math is super simple. The algorithm is super simple how to do this. But how to track this effectively without taking massive amounts of memory, because you can't store the tree all the way down to the leaf nodes. We're going to really have to say, well, how deep do I want to track the tree? The deeper you go, the better your logic is. The more iterations you do, the better logic is. The problem is the deeper your tree is stored, this adds up memory time, and the longer it's going to take to store to calculate moves because you have to update the tree. And I'm just keep explaining this until I see where I end up in the reader board. And okay, we're not going to make it up. We might make it up if we wait long enough, but we're going to actually have to start working in that tree. So let's make a test function that plays the game from beginning to end, and that'll set us up to do it correctly. And we'll just let this sit here, because if there is a good chance, based on our strategy, that we could... Oh, we're so far away. These people have strategies, so no. Okay, let's put... Position 13 is with, like, no strategy. This is basic rules of the game. And we probably don't have to get forward, so definitely I think a one-move look-ahead is probably enough to get us out of this league. And then we're going to set it up that we can just do multiple moves look-ahead in that case for depth of the tree. And let's store this before I go mad. Full rules. Well, not quite, but close enough. And I'm going to look at all these warnings because they're starting to annoy me. Unused macros. No, I don't care about unused macros. Allow unused macros. Those are also okay. Let's cargo check that. Unused variable. So we're going to clean those all up so I have less things here. Control U36. Alt player. And I have it twice, that's why it's not used. That's why we do these things. Unused variable I, this is in 49. Yeah, that's fine. That just discard the rest. So as you can see, we've totally discarded the valid move input. This stuff here is totally unnecessary. We don't use it at all. 56. And why does this doesn't need to be mutable? Does it detect that I've assigned only once here? Okay, interesting. That's a nice feature. Cool, I didn't know it can do that. Most other languages can't do it. Most other languages would bitch at me about something like that. Like if you didn't assign a value here, they said unused, but it's actually tracked that these are all assigned to and there's no. So that's good. 51, Control G 51. How do you ignore a result again? Was it just like... Or let. Is there an ignore, an explicit ignore? Okay, so we got it really clear in there. And I would really love if RLS worked for us again, but it just doesn't. I don't know why, and it's kind of annoying. The thing about the double main file, ePens is going to work on that and fix it for us, which will be great. So this feels like too much logic done in entry, and that's correct. So now we actually need... Well, we're going to need to clone the state. Cloning state's going to be expensive, but there's really no way around it. Do we have state being clonable? Clone. So we know we have these two use sizes here, and that increases the size, but I'm not going to worry about that right now. Technically, they don't have to be cloned in the next step we're going to do. Actually, do we even need them here? We don't. So I'm going to move them out right away, actually. so that we have the minimal part that we want to clone as that part. And just trying to think of names for this. This is the game state, the board state. And the other one is called, what is the other one called? Small board? And we'll call this one board state. Board state. And then we're going to do public struct state for the full state. And this will have a board state. Moderated seal. Well, so far we're using nothing but stack allocation. That is the advantage of the borrowing system, is that all these references with the lifetimes and stuff, it just all gets allocated on the stack as much as possible. Strings are different, invex are different, they get in a heap, but everything else as far as possible stays on the stack, so it's quite efficient that way. But that's as far as I got for that. Reknakas, it makes sense that you don't get by bronze with everybody using random, because it's going to be 50-50. Mine is slightly above 50-50, which means he might slowly sneak up there, but it's okay. So we have state, and I got to see how much. This print is for the board, so it goes down there, get board index, take turn. Take turn, these are all part of the, so the state itself has nothing. The board state, it's all part of board states. Import board states. And the super state here has, or the main state has player and alt player. And we do need to have that because it should be stored somewhere for reference. It's just the individual board state doesn't care. It doesn't care who those players are. Except when we go down here, when we say state.board.takeTurn, then we're going to have to do that for everything. State dots. Most of the state dots here are going to become state.board, except the state.player. State.board. State. No, that's state.altplayer. State.board. State.board.bigboard. State.board.smallboards. State.board.smallboards. We might want to change the name just to small and stuff, but I don't know. State.board.takeTurn. State.board.print. State.board.bigboard. And I'm no longer liking these names, big board and small board. They might just be called small and big. It simplifies it a little bit. And let's do cargo test. Get the compile errors. Oh, well, that's a problem there. That was supposed to be public. I should have it clear here. This is state.rs28. That must be in the test case. I should have called the test case something else, because I can't see in there anyways where the directories are. s.board.print. And we have another state down, s.board. S.board. And I'm going to take out that small and big board stuff. Once I verify that this works, I'll take out the small and big board because it's been very clear what the names are. Okay, so we're going to remove this right in the state. We're going to say small boards. We're just going to say small and big because this simplifies it. So let's look for small somewhere. So we just say self.small. Self.small, because this is now a board, self.small. And big becomes self.big. Ah! And an entry as well, we're going to say small. And there's a big as well. Gets rid of. Searching does do the wrong thing. And for the test, we have to do the same thing. Small, if we even use these things. Small and big. And that clears up the naming for us. And we have unused stuff. Why? Huh. Oh, we don't use that macro. Just get rid of it for now. 27. Oh, wait. The rules for unused macros don't apply? Well, let's just comment this out then if you can't put an underscore on it. Strange, that doesn't make consistency. Okay, so at least that works now. And see, I wish I could get it to tell it to just run one directory, because it's running a whole bunch of different directories here. And I don't know why. I just want it to run the one. And we're stuck at 13, which would make sense. Usually it shows going up and down. Is there nobody playing games? Why are there no arrows in anybody? The arrows are gone from everybody. It's weird. There's a lot of people here right now. Okay. In any case, that cleans it up, and we're going to commit that again. We're going to do nice things. Clean up names. Oops. AM. Depending on that. And now we actually have to make it play a full game. And we need that. We need a strategy class or a driver class, a strategy class. And how do we want to do that? We're going to have a strategy class. Good. Not here. We're going to have it in strategy. And I'm not sure what I want to call this. Yeah, we'll just call it strategy. That's fine. Use state start. And lib is going to have to be hub mod strategy. And we're going to put that in the test. We're going to test the states. We're going to put a new test for that as well. And what do I want to do here? What was the idea here? I want a function that gets the best move. That's the most logical one. Public function, get best move. And we need to know for which player it is. We'll assume it's his turn. And the board index of where they can play. This is going to be really challenging for where they can play, because you basically have two starts of the evaluation of the tree. If you can pick anywhere, then your evaluation starts higher up, and that's a real pain. Yeah, that's a real pain. Where can they play? Actually, we need a state as well. For the current state and state for this player and where they can play. And the best move is going to be a tuple. We're defining turns that way of use size, use size, use size. I wonder if we should give that a name or not. And so this is currently the best move. And we're going to start evaluating. We have to determine if the game is over as well. But we can do that in a test loop. So get best move. How do we do that? Well, let's start with simulating the whole game without getting the best move, just by getting the next move. Okay, so we basically say, we take the logic we had from entry, and we're going to copy this. And we'll copy this over afterwards. I'm just working in steps. We want to simulate the whole game first of all. And so if we have nowhere to play, we're going to take the state big board next free, blah, 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 next free QX. It returns all of this, and then we return SBX, NX, NY. And we can actually replace this right away up here. Use strategy star. And do it this way. The next move is going to be let SBX, NX, NY equal get best move. Get best move, and we set its force and state. And actually, this doesn't need state. This doesn't care about state. This cares about, what we call it? Board state, I think. Board state. It only cares about board state, and that simplifies it. And that's the simplification we want there. Board state. State.board, because it separates it out, and state.players, who's going to play it, and this is where they're allowed to play, and this all goes away. And then they take that turn there. And that's correct. They take that turn. That's all we have to do that there. And that should be enough to just keep working. Cargo check. We shouldn't have any errors now. And state and strategy, we match where they're allowed to play. This is where they're allowed to play. And we don't have to do big board now because we just have that board. And that looks okay. I guess you shouldn't think it's called where? Yeah, okay. Let's call it forced. They're forced to play board here. This makes sense where they're forced to play. Param player whose turn it is and which move to calculate. Param force position where player is forced to play. Big board position where the player is forced to play. There we go. And well, I took off the wrong thing. I took off the state instead of the board. State state.small. State.small. Why would I want to do that though? You mean you can use keywords? Yeah, no, that's not necessary. I can just change the name. It's clear enough. I guess that's if you're doing code generation, that makes a lot of sense. When you do code generation, it's really nice to have a way you can just force to have valuable things in there anyways. Okay, player's not used, that's fine. We don't use him yet. So this is our main game. We take the board, we take the turn. Yeah. And introducing new keywords is always annoying. I have the same problem with when I do my language. If you introduce a keyword, you can break a whole bunch of stuff, but oh well. Alright, so we read that, we discard this nonsense here, discard the rest, it's just total crap. And we should probably have a read state. Aha, okay. I'm not going to make a separate reading here because this is fine. We don't need to yet. I'll wait for it. There aren't valid identifiers. Wonderful. Yeah, because if you have a library, or something with an old name, edA-qa says it's giving us a way to call names in the next version that aren't no longer valid. But if you already have a library and you're using that library, you need a way to call stuff in that library. But it'll be 2019, 2020 before coding game updates, so we'll see about that. So that worked, and let's see if it's still working here. So we lose, but you can watch it play, so it's at least fun to watch us play the tic-tac-toe game. And it's totally random. Okay, so now we're actually going to have to iterate through a game. And the reason I set up the strategy is get best move, it returns the next move, because now in the test strategy, we're actually going to set up a loop to play the game so we can test this to see if the game logic is actually working. We can actually test it and see who wins a game or not. And we can make this get next move and get best move, so we can do either one of them. And then we should be able to make a test program that forces who wins, and that's how we can test it locally, because we can play against ourselves locally, because we know other people are going to have the basic same strategy in the end, and so we can test it locally. But we need to have a test code here, and I'm going to save this one here, and I'm going to call it strategy test. I'm going to call it test so it has a clear name, because they don't show up well in this program where it is strategy.test. And we don't need this. And use tic-tac-toe strategy. No strategy. No. Oh, come on! Why didn't it work? Strategy star. And we're gonna do a play game, play full. And actually, you know what? This shouldn't be a test code. This is just going to be driver code. Because we're not going to run this in a test. We're just going to do driver code. So let's just back out of this nonsense, save this, and close that. So we're going to make a separate main program there. You know, I don't like this in editors. They shouldn't have marked this. Give me the chance to delete this. They should have marked as being able to delete it here, because now I have to find that stupid file somewhere else. RM test strategy. RM, not FM. Okay. So now we're going to look like we're going to open the main program here, bin main. We're going to create a second main program. We're going to call it, let's call it local. I don't know what to call it. Let's call it play. Use tic-tac-toe. Can I just use tic-tac-toe star? Let's do state star. Use tic-tac. It's a terrible name for a crate. It's annoying to type. So we don't call entry. Now we have a main. And now we're going to create a state. Let mut s equals state default. And we have two players. We don't even need that. But that's okay. We'll do that. I'll just make sure this compiles first. Print line I. So we want a cargo build play. Anybody know how to build this particular program? The hell is RLS? Debug. There's a play. Well, it's fast enough. We don't have to worry about it. But somebody could tell me how to run a particular program. That'd be good. So clear and cargo build and target slash play. Debug. Target. You know, I totally forgot about cargo run. Clear and cargo run dash dash bin play. Hi! Thank you! Thank you, Crazy. You know, I should be writing this stuff down, to be honest, because I'm going to forget it again. And let's do that correctly. All my projects of forgotten things. don't really use the cheat sheet. That's not what I wanted to open. I wanted to open the README so I can look online. Rust commands. And we're going to do this one. We're going to do... See, I've already forgotten what it was. Cargo run -- bin name. I don't have to remember these are. And what was the other test one? I wanted the one that gets the outputs. Cargo test name -- no capture. Alright, and those will go online eventually whenever I push that next. Close the cheat sheet, close this untitled one. And let's go back wherever I was to cargo replay. I don't actually know why it compiles every single time. You think it'd realize that nothing's changed. It's a bit weird. So now we actually have to get this to play the game. And we're going to do this. We're going to say let mut player use size equals 0. We'll start with player 0. And we're just going to do a loop. And we're going to do a match s.board.big. We don't actually need the board. We don't need the state. We just need the... whatever. Let's take board.big.getState. Game result closed. Then we print line. This is a tie game. Tie game. And break out of the loop. Game result win. PL, whoever the player is. Print line wins. PL. Otherwise, we just continue. We keep playing in this case. So we loop, we keep playing, and this is the end here. This is the end, the game over. And each loop of the game, let's print it out. Or maybe not. Let's make a state.print or board state.print that prints both of them. Actually, never mind. Let's let it play first. And let's see if it wins or it crashes on us. Okay, so let move equal... can't call it move. Move equal... get best move. This was s.board. I'm going to say it's player. And we're going to have the last move. Let mut force equals board index none. And that's the force here. So we're going to get their best move. And then we're going to take their move and set force equal to that. Force equals s.board.take-turn. And this is supposed to be s, x, y. I don't know why I represented it that way, but okay, we're sticking with it. Let's take turn, and I don't know what take turn looks like. Take turn. Player SXY. And this is player SXY, and that returns the force for the next player, so that makes sense. We put it there, and we're doing s.board.print. s.board.big.print. We'll print both of them out. That's the final thing the game does. And this should keep taking turns until the game wins. And this looks at the big board. The big board, until the big board is won or closed or done, then we keep playing it. And we're going to see if this actually works. And they're both going to take their next move, so it's going to be really simple. Use size is a primitive, and therefore... oh, I guess I can't call it that, SB. Well, I probably shouldn't have called state S, but that was kind of silly. And, okay. Yeah, well, if X keeps taking turns, naturally X is going to win. Player equals player plus 1 mod 2. So we have to switch players. Let's go to the next player. And let's get this big enough so we can see the results. Okay, so 1 wins. Whoever 1 is, I guess that's O. And the big board is O, so 1-1. And this is going to be consistent. This should be absolutely the same. This final board should be the same every time we run this. Cry said that is actually correct, but I'm not going to do it. And I'm going to explain why. Because, well, first of all, I actually never use bit operators unless I'm doing something on bits. And this is a high-level logical operation for players because that or equal only works if it's a 2-player game. And, you know, if you had a 3-player game, it'd be like this and like this. And so this is logically the structure for rolling around a loop like this. It just so happens in the 2-player game you have a separate optimized version, but it's for that reason I wouldn't actually use that version because it's less clear. Okay, so every time we play this game, we have the exact same results, which makes sense. And why does this rebuild it every single time? This is stupid. Come on, Cargo, stop this. Stop recompiling every single time because that causes it to get spit up here as well. Hey, look, we're at a solid 13. And this is actually really weird that we're stuck at a solid 13. It looks like the game somehow broke. Nobody's submitting. Nobody's moving in the ranks anymore. That's just weird. The game's really stuck. Yeah, Cries, this is what I'm thinking too. Why is it recompiling every single time? Alright, so to check this is working, because this is not satisfying, but you see how many moves in this stupid strategy, how many moves you have to play to get the full game. I'm going to make a random strategy as well. And it has the same formula. Cries, yes I do. Is that a problem? Ooh, yeah, that's probably why it's rebuilding every single time. I have a build equals bundle rs, and that's what bundles the file together. I didn't actually want to do this, but is there some way to just bundle on demand? I'd love to just run this one on demand, but I didn't know how. So like in the cargo toml, I don't want to run this every build. I'm happy to run a separate cargo command like I'd really like to say like have something like xbuild or bundle. I'd really have something bundle and tell cargo it has to bundle now, but I don't know how to do that. If somebody could tell me how to run this on demand, I'd be much happier. Yeah, but it needs to hook into the or wait. This is just a normal program, isn't it? Is this just a normal program? I don't know if I just set it up the way ePen said. There's one way to test that. If you go to tic-tac-toe source bin and call it bundle. Bin bundle. Oh yeah, I gotta get rid of that first. Strategy, let's get rid of this first. Ew, well, now it doesn't like it in there. But here it is right here. So something about it doesn't like it. It doesn't find the external crate now. Alright, I don't want to do this right now. But that would be something I can look back at, rm source bin bundle. That'd be something nice to get set up. But we're going to do it the other way now. Play. We're going to make a random strategy so we can actually see different outputs. And that gets us back into actually doing weirdness again. Cargo workspace. I don't know what a cargo workspace is. Oh man. Let me write that down. Cargo workspace. That doesn't sound like something that's exciting to do in a live stream, so I'll set that up otherwise and maybe reinstall ours. Because RLS is also looking for workspaces. Maybe it'll work better as well then. Okay. Alright, well, I'll see what happens. I'll see that. Now we have to do random. Get random move. Get random move is a bit funny. Well, RLS has problems now. RLS already doesn't work, so it can't get worse with workspaces. How do you actually do a random move? This is a good question. How do you do a random move? Well, first off, we do this. If force equals board index none, we have to get a cell. And we're going to do let. We're going to do the same things here. We need this thing. We need to know what index it is at SBX. Else SBX equals force. How do you unwrap a specific enum? There must be a way to, I don't know how to do this. So there must be a way to do this without a match, and I'm not clear how. Yes. Because this shouldn't exist here. Oh, there isn't! Okay. Well, we can restructure this whole thing anyways. Just do it this way then. Board index none. Now we'll just do it the compound way. And now we just have to look through. If we can go anywhere, we're just going to look at all the possible ones and find something random. Okay, I get it. I get it. So I'd have to implement that myself. So there's an option I can implement myself. I don't really need it yet. So now we actually want to go through here and return a random index from the board. Now, randomness is funny in how it works. If you want to return a random index to the board, you have two options. You can get all of the spaces that are free and grab a random one from that resulting list, or you can keep checking random spots until you find one that's random. If you try to iterate and move around, you're going to get invalid results. Cryos, yeah, that'd be cool. That sounds like a derived thing where you just do that for all the standard ones, yeah. Metaprogramming. I haven't looked at metaprogramming yet. I have to look at it sometime. Okay, so the question is here, given a board, how do we get a random free cell? What's the easiest way to get a random free cell that doesn't actually cost very much? Something, although we're not probably going to use it in the real game. Now we're going to have to actually use it, yeah. Well, we're going to put that in state then. We actually need something in state to get a random free cell. And that goes on the mini board. And this is actually important. Public function random free. and self gives us a usize, comma usize. And actually, you know what? I'm going to start probably this x and y nonsense. We should probably collapse this in just a linear index, because as I said before, these cells aren't really a matrix. They're presented as a matrix, but they're just 9 random board squares. They could be presented as a circle with odd rules in any way you want. They're presented as a matrix for convenience, for human consumption. But the actual game, we're going to actually do a lot better speed-wise if we convert this to just using a linear index between 0 and 9. But for now, I'll stick with it this way. And this random free, wow, this is going to be really... I need a super fast way, given a set of 9 indexes, that could be filled. What's the fastest way to give one that's random? Well, let's work this way first. The random number generator is going to be the biggest problem here, actually, in speed. The one where we have to grab it every single time, but we'll worry about that later. Okay, random free. So we're going to count free, first of all. And how do we count the number that are free? Wow, this is going to be slow. 0 dot dot. Board num cells. Yeah, that's what we want. Board num cells. I hope I can do this. Map x as self.board. Oh, we need to combine the board. Let used equals self.board 0 or self.board 1 or self.board 2. Used and 1x. I'm going to map this to a count. This is really weird how I want to do this. We put map x. What I want to say is that not equal 0. If this does not equal 0, then we map it to a 1. Else 0. There's got to be a faster way to count bits. Oh, come on. I don't know. This is something to look up for optimization. To do fast ways to count bits. And to get the first bit. Anybody know any bit operations? I need to count bits and I need to get the first free bit from a used thing. We're going to look that up. Rust count bits. Maybe there's a package for this, if I have to spell it correctly. Rust count bits. Is there anything here? I want to be able to count bits. Given a number, I want to count how many bits are set. Count ones. Delightful. That's exactly what I want. Use.count ones. That saves me lots. And so this is actually board num, whatever that was, board num cells. This is the number of free cells in it. Okay, so now we have to do random numbers. How do we do random numbers again? When's the last time we've done random numbers? That was in, I don't know. Random number time. That was in, what the hell did we random numbers in? Great Dispatch? Great Dispatch had random numbers. Here we go. Create rand. State. Create rand. where's the next random? Rand. And we did that with, where's our rand in here? Not here. Random. Thread RNG random get range. We should probably pass this in, but we'll worry about that later. Gen range let free equal to range dot gen range 0 to count as use size, and this gives us the next free one. Okay, now I have the next free space, and I have to find the empty one in this 0 here, so the next 0 that has an empty space. How can I find the first free 0 in a binary number without doing a loop? Do they have that? No, we can do it this way. We can do loop if free equals 0 break. Yeah, no, that's not quite, is it? What do these from functions do? Oh, from big endian. Trailing zeros. No. Okay, I'll do the loop and we'll see if we can figure it out later. Fast way to find empty bit. And oh, I hate doing bit stuff. Why did I use bits for this? So we have these board bits, and I'm just trying to find the empty bit. Let's do it the worst possible way first. Bit at equals 0. That's cell equals 0. And we have to spin this. We have to do while used and 1 equals 1. Used, I'm going to shift it right 1 to get rid of it until we find the first 0. Once we find the first 0, so we find the first 0, good. And at plus equals 1. Otherwise do free minus equals 1. What I'm trying to do is I have this count. We have free, and free says, so if I had 3 of the bits in a pattern, so let's simplify it this way. So we have this count, this used up here, and it probably has a pattern like this, 1101101 or something like this. And so count here ends up being, so count equals 3. There are 3 free ones. And then free ends up being some random number like 1. And so what I need to do now is say, well, the index at 1, so it's the first, so it's not, we're going to count up to 1, 0, so not this 0, so this has to be the result, has to equal 3. No, 2. The index base. So what it's saying is the index, the index of this bit. So we're saying skipping over 1, what is the index of this bit here? And so if free, we said 0, so we want free 0, then it has to find index 1, because that's the first index here. And if we said free was 2, then it has to go over and find index 5. No, free is the range. Free has to be random. Free is random. Free is a random number. So basically all I'm trying to do is, given this number, I'm trying to find a random one of these zeros. So yeah, given a binary number, tell me how to find a random one of these zeros in it. That's probably the easiest way to explain it. Overall, so I have some binary number and I have to find the random zero in here. And this is what I'm trying to do now is I have the random, we have the count, I can do that. And this is all set up to just find that random zero. I mean, it's going to be a pretty tight loop in release mode, but in debug mode, this is going to kind of suck. And but there's a better way here. At equals 0. Well, used an at equals 0, then we can shift it. We can shift at. And do this way. So as at, it's going to find the first 0. So this finds a 0. And if free equals 0, we break. Otherwise, free minus 1. And we keep looking. And we keep looking. So now at has... Now at matches the index of the first 0. Trailing zeros. And now we have the number of trailing zeros. Index equals at dot trailing zeros. And this returns index. And this is x comma y, so mod board size. Index divided by board size. Now we're going to come back to this loop here because this thing here has to be extremely fast. Because we're going to be calling this millions of times. So whatever we do here, this has to be called millions of times and this has to be super fast. That's going to be annoying. So if anybody can think of the fastest way to do this, given a set of bits, give me the index of the first, or give me the index of one of the random zeros, or a random zero index. And there's got to be a fast way to do that, faster than this. But we're going to go with this for now, random free. And assume that works. So over in strategy, we're going to say board index equals... Now we're going to need to see that in code. Binary search, shift away. Oh, come on. But remember, I need a random one. That's very important. I need a random one. And let's x comma y equal state dot big dot random free. And this conversion back and forth between x and y is going to kill us. So I'm going to have to... Tomorrow we're going to convert it all to linear indexes. We'll leave the xy for convenience for test, but otherwise we're linear indexes. Because right now this is going to become y times board size plus x. Wonderful. We've just undone what the other thing did. So that gives us the board index of the big board. It's an SBX. And now what do we want to return? Random move. We're going to say the real xy is going to be equal state.small SBX dot random free. And then we return SBX xy. And so this is a random move. Will that actually be faster, a binary search? It may not be faster, and this is one that's going to be a real pain in the ass to test because a binary search involves a lot more a lot more conditional logic. And this thing here, and this again, we're in debug mode, so we have no idea. This is just random here, totally random. If we had a way to force this, I imagine in release mode, this would actually be compiled down to something that has only this one condition here, and this other stuff, I don't know. We'll have to figure this out. We'll do some benchmarking later to see where the speed issue is. But this random free is going to be a huge kink in sort of our speed because it's going to be super slow. So play. Let's make them take get random move. So our play function now should play random games instead of best move. Others saw, yes, obviously for the first level of the tree, I'm not going to do random. For the first level of the tree, I'm going to store all of the open ones. And then just keep using that. So it's going to be all of the open ones. It's just as we walk through the tree down, at every single level, I need to actually do the random thing again and again and again and again. But there are ways we can do it. You could actually, the quickest way to do it is probably just take a random number between 1 and 9 and check if it's open, and if it's not, just increment from there. That's probably the quickest way. It's not totally random, but it'll be random enough. So like a hash index thing. So you look for, take a number between 1 and 9 or 1 and 8 and check, is that cell free? If it's not free, just check the next ones until you have a free one. And that would be probably the fastest way, and that might be random enough because we assume we have one free. All right, see if we can play something. Oh, we have errors. Of course we have errors. Did you mean self-rand? No, I didn't. Why the hell would I mean self-rand? And that's fine. Oh. How do I use do we have to put something in the TOML file? Rand. Would be helpful. There's a bit set there too. That might become helpful some other way. Where's our cargo TOML dependencies? Waiting for locks. What the hell is using those files? Alright, if random works, then I'm going to be done for the day though. Because I just wanted to get this working. I want to see it play random games. And that will be enough because we start tomorrow with the basis of the... Ignore that first bit first of all. Expected use size. What do you mean? Count ones? Oh, that's right. Or as use size, or whatever the hell it is. No method named gen range, rand. Something's weird there. Expected bool found that. No method named tailing zeros. Maybe we want trailing zeros instead. Alright, what the hell is this? What's this? Did you mean self-rand? I don't get this. Why is it getting mad at me? Why can't I do extern create rand here? Well, this used to work. Why does it not work here? Or does this have to go in libs? Oops. This goes in lib, maybe? Extern create somewhere? Oh no, that's not what I want. I put that in the wrong... Shit, I put the wrong one there. Why self-rand? Well, can I just put it in lib, though? Does Doesn't make a difference, I guess. Okay, so you're saying I do this and I use self-rand. That's weird. 160, 160. What's the problem here? Cannot assign to... Uh-oh. So x1, 0 wins. 0, I guess, is x. And we play it again, we get different board states. I guess I don't have to recompile. We'll see this board output. We get different wins every time. So, targets / debug / play. Different output each time. 0 wins, 0 wins, 1 wins. So this looks like random games. So we have randomness working. We play completely random games. This is perfect. We have the output. So we can play a game right to the end. Now in one session of the actual bot, we're going to be playing millions of these, not random. So this is the complete random strategy. 2 players playing randomly. And it's great that we can do this locally, because then we can simulate whatever we want. I pressed up twice, but... So we have the complete random play of Super-Tac-Toe now. We can represent that randomly, or visually. I don't know why I keep pressing this. It's just fun to look at the output, see if it's actually random. We don't get any crashes, but that random function there is going to be a crux to us. That we're going to have to make that super fast. And the way we can probably do that is just do pseudo-random as well. I mean, it's already technically pseudo-random, but there's ways we can speed that up because Monte Carlo doesn't strictly need to be random. You can do different things with it. Alright, so I think that's all I wanted to do for today. It's getting late now for me. I usually start late, but I've been starting early. And that means tomorrow when I get a start, tomorrow I can actually go through and actually start doing the Monte Carlo sampling further down. We can actually implement, and I'll explain how that works. Now that we have the random strategy that can do a get random move, and we have this play, we're actually going to duplicate this play function into strategy and play until we have a winner. And that's what get best move is going to do. It's going to do exactly what play is doing now. It's going to set up the game, it's going to copy it, and then it's going to take moves down to the bottom, random ones, random moves, and it's going to score it, and from those random moves, it's going to say, well, you know, this is the best move for the next player now, and it's going to give it back, and it's going to just do that as fast as it can. We have 100 milliseconds. I think the game said 100 milliseconds. Oh, we went round rank 15. Oh, 13. So we have 100 milliseconds, which, again, if this were compiled in release mode, and assuming that bit stuff optimizes and the tree optimizes, we should be able to do millions, if not billions, of samples through the tree. And actually, no, whole games, we should be able to do a couple million of them. But because we're in debug mode, we might get lucky to get done a couple thousand, which is going to be a serious problem. So a couple thousand is going to be an absolute serious problem for us. So but the strategy we do tomorrow, when I set this up tomorrow and Sunday, we might not. We'll see how far we can go, because if we're just getting hurt, we should be able to easily make it to the next league with thousands. But how far we make the gold of legend is going to be strictly based on how much we can pump out of Rust. And the other guys that have optimized code are going to have a definite advantage. But the random Monte Carlo sampling, we can tweak it a bit here and there. But the actual way to get better results is just run more iterations. As much as we tweak it, the guys doing C++ optimized code, anything that has optimized C optimized code are going to be the guys that sit at the top of Legend, because whoever can evaluate the most moves wins. It's really that simple. The logic you can do, the pruning logic is really important, and so ours is going to be awesome at pruning because we know we have that problem. But again, the other guys are going to figure out the pruning rather quickly as well. They're going to prune, do optimization, and boom, they can just do more operations. It's going to come down to whoever can do the most. And obviously in debug mode, we're not going to be that person. The guy probably in C or C++ is going to be that person. And they're going to hand tune it quite a bit. I don't know if anything else get down there, but we'll see. But I think that's all I wanted to do today. I'd like to do more, but again, next sore and getting a bit tired. I started early, but that should be enough. So we have this git status, and we can add these files to it. And so we're set up for tomorrow. And crazy, yeah, we're forced to debug mode. That's the really shitty part about it. We got hurt in the Tron game. We just gave up on Tron because we saw we had no way of progressing. And I knew that here. I knew going into we're going to get hurt by that. But I wanted to do it anyways because Tree Monte Carlo is really fun. And it's a nice thing to do on it. It's fun, and we can show how it works. And eventually, sometime this year, we'll get release mode combugging, and we can go back to whatever games we played and get farther in the ranks. Sample gameplay. Because, yeah, especially... Christ, no, we don't get to do that. I don't know if you're aware of what's actually happening is that we're using the bundler, and that's what that bundle file is that we submit a single file to Coding Game. So we pack all our code into this one big file. So if you can't do it inside a single Rust file, you can't do it. So there's no cargo toml or anything submitted to the server. And Reknakis, yes, you've said Bomberman before, and we'll get to it. After this competition, we can do Bomberman. And we'll eventually get to all of them. And until the next contest comes. But we'll see. We have no pressure here. It's not the competition. I don't have to work offline to get this. I can just wait till next time and see where we are. But I think we're at there. So, Cries, no, there's a few basic crates you can use. Random is one of them. We have no idea what other crates are installed. Somewhere is the list, but there's very limited crates you can use, and that's actually an issue. I think I wanted to use Bitvec before, and Bitvec was not one, or wasn't one of them. But yeah, every time we use a crate, we have to check if it's actually allowed to be used. That is an issue, and so we're greatly limited here. And hopefully sometimes this year will update it, and we'll keep pushing them to update it. So if you guys from Coding Gamer happen to watch this segment again, please update Rust, let it compile to release mode, and I don't know how we install crates, because installing crates is a big issue because they can't obviously allow every submit that we rerun crates. So I don't know what to do. Just install more standard crates. Just take the whole pack of default crates. Okay, but tomorrow we'll get to the actual Monte Carlo sampling. Today we got the random playthrough, which is one of the core steps we have to do. And so, thank you guys for watching, and we'll see you tomorrow evening.